Good afternoon, everyone. We are from Group 78 from Engineering in Society, and currently we are doing a project for Hindenburg Disaster in 1937. So our group consists of me, myself, ABDUL bin SATTAR, and Aimran bin SARBINI, LUQMAN bin FAZLI, ATIRAH MASYITAH binti MAHIRAN, and TARANIYARASY anak perempuan KALIDASS. Assalamualaikum and good morning. My name is ABDUL, and I'm going to move on to the introduction part. So, on May 6, 1937, the German airship LZ-129 Hindenburg attempted to dock at Lakehurst Naval Air Station in New Jersey. Suddenly, it caught fire and was destroyed in less than a minute. Of the 97 people on board, 36 lost their lives, along with one crew member on the ground. The entire event was witnessed live and captured by the media, making it one of the first major disasters to be broadcast around the world. The Hindenburg was considered a marvel of engineering, a symbol of innovation and progress in air travel. One of the biggest tragedy exposed how engineering decisions when made without fully considering safety and ethical responsibility can lead into devastating consequences. One of the biggest issues was the use of hydrogen gas, which is extremely flammable. Engineers originally planned to use helium, a much more alternative, but due to political tension and restricted helium supply, they chose the hydrogen instead. So this showed how external pressures like politics and also economics can strongly influence engineering decisions. The disaster raises critical questions. Did the engineers and the decision makers properly assess the risk? Could the loss of the life have been prevented? Thus, the Hindenburg reminds us that the engineering is not just about building technology, it's also about protecting the people. So it also highlights the need for the engineers to think ethically, prioritize all the safety, and also to consider the broader impact of the work on the society. Thank you.
The sequence of events that led to the Hindenburg's final journey began on May 3, 1937, departing Frankfurt. After a 3-day transatlantic flight, it arrived at Lakehurst, New Jersey on May 6. At 4:15 p.m., it reached Lakehurst, but severe weather over the New Jersey coast forced a delay. By 6 p.m., conditions improved, allowing the final approach. Around 7 p.m., the airship began its landing maneuvers, attempting to compensate for shifting winds from easterly landing in the beginning to a tight astern for southwest landing. Crucially, at 7:20 p.m., the forward landing ropes were dropped. A few minutes later, the ground crew noticed a suspicious flutter, a likely sign of a gas leak. Then, at 7:25 p.m., flames erupted at the stern, rapidly engulfing the entire airship in less than a minute. Only 62 passengers and crew out of 97 survived the incident. The list below name all the stakeholders involved, and it is important to note that official investigations did not find any of them are directly liable for negligence. The cause was attributed to a combination of factors, primarily a hydrogen leak ignited by an electrostatic discharge. However, under the Warsaw Convention, the operating company had a presumed liability for passenger compensation, which was typically covered by insurance.
Assalamualaikum and good afternoon. I am Aimran from Electrical and Electronic Engineering, and today we will discuss the technical issues that caused the Hindenburg disaster. There are 3 crucial things. First is the usage of the hydrogen gas. During that time, there was a ban on helium gas by the United States, and because of this, the company had decided to use hydrogen gas, even though it is known as very flammable. Second is the structural fatigue of the airship. A wire was snapped and slashed the hydrogen cell tank at the back of the airship, causing the leaking of the hydrogen gas. As can be seen from the footage, the fire was spreading from the back of the airship to the front part of the airship. And lastly, lacking of the electrostatic discharge mechanism was the main factor that initially sparked the fire.
The Hindenburg disaster wasn't just a technical failure, it was an ethical collapse. Analyzing it from Malaysia's Engineers Act 1967 reveals 3 key ethical violations. First, engineers chose flammable hydrogen over safer helium, prioritizing cost and politics over passenger safety, violating the principle of holding public welfare paramount. Second, political pressure forced engineers to ignore dangers, as the airship was a Nazi propaganda tool. This violates BM's Code of Ethics Rule 3.1, requiring engineers to resist conflicts of interest. When politics override safety, disaster follows. Third, there was a shocking lack of transparency. Passengers and crew were never properly informed of the extreme risk they faced, which is a clear breach of BM Rule 5.1, which demands honesty and full disclosure of hazards.
As for recommendations, firstly, modern engineering must start with hazard identification and failure mode assessments. Regulatory bodies should enforce risk audits and safety checks before any high-risk system is deployed. Secondly, critical components must go through stress testing, fatigue analysis, and real-time monitoring using advanced tools like finite element analysis. And designs must be built with fail-safes to prevent disaster from a single point of failure. Thirdly, we must also protect against electrostatic discharge, especially in large structures. Grounding systems, park arresters, and routine system certification are no longer optional, but they are essential. Lastly, engineers must be empowered to act ethically. Political or commercial influence should never override safety. Independent ethics review boards with the authority to assess and intervene in engineering decisions are vital. The Hindenburg disaster reminds us that when safety and ethics are ignored, innovation turns dangerous. Design flaws, risky materials, and political pressure led to tragedy. Engineers must uphold responsibility, transparency, and public safety because true engineering serves humanity, not ambition.